Hi guys, today we're going to cover the last section in chapter 5.6, exponential and logarithmic equations. So pretty much by this time, things to know, you need to know everything from the previous sections in chapter 5. So all the properties. So you need to know all the properties about logs and how to change from log form to exponential form. And vice versa. So basically, you need to be able to change from log to exponential and exponential to log. And then we're going to solve log equations by hand and the exponential equations by hand. And those some application problems. Okay, so in general, when we're solving an exponential equation, so exponential equation, again, if you remember, means it has the variable in the exponent. You need to use log in some capacity. Okay. Now, there are some instances where you may not, and we're going to look at those first. And which these type of problems are kind of specific. And so we'll take care of these first, and then we'll figure out the rest. So here we go. First problem: 2 to the 2x plus 3 equal a to the negative x. Okay, there is a property that says if something raised to a power equal to something raised to a different power, and notice they have the same base, right? If two quantities raised to different powers but they have the same base and they're equal, then the exponents gotta be the same. Okay, so for example, if 2 to the b equal 2 to the c, then b equals c. Alright, now if you look at the question that we just wrote down, 2 to the 2x plus 3 equal a to the negative x, can we rewrite this so they have the same base? Now, that doesn't always work, but in this case, I think we can. Notice, 8 is 2 to the third. So that means 2 to the 2x plus 3 equal to a to the negative x. It's the same as 2 to the 2x plus 3 equal 2 to the third raised to the negative x. Okay? And now, check this out. We now have the same base. So let's kind of simplify things really quick. 2 to the 2x plus 3 equal 2 to the... Now remember, when you got power raised to another power, you multiply the exponents. So this is a negative 3x. Okay? And now we have the same base. They're equal. So therefore the exponents gotta be the same. So this implies 2x plus 3 equal negative 3x. Solve for x, you get 3 equal negative 5x, and x is negative 3/5. Okay, so x equal negative 3/5 is the answer for this problem. Okay, alright, part B. E to the 4 over e to the 2 minus x equal e to the third times e. Alright, so remember your exponential properties. First thing first, I can treat this e right here as e to the first. So this means e to the fourth over e to the 2 minus x equal e to the fourth over 1. Okay, and now check this out. If you cross multiply, right? Because this technically is a proportion. So if you cross multiply, you get e to the fourth equal e to the fourth times e to the 2 minus x. Okay. So now check this out. So this is e to the fourth equal e to the. We can add these together. So 2 minus x plus 4 is 6 minus x. And now same thing. Same base. If the bases are the same, that means exponent has to be the same. So that means we have 4 equals 6 minus x. So x equals 6 minus 4, which is 2. So x equal to 2. Alright, part C. Yeah, 27 2x plus 4 equal 9 to the 4x. So it looks like we have 27, 9. I think in this case, we can all agree that 27 is 3 to the third. And 9 is 3 squared. So, simplify the left-hand side, right-hand side. We multiply the exponents together. You get 3 to the 6x plus 12 is equal 3 to the 8x. And again, the bases are the same. And this is equal, so we know that 6x plus 12 has equal to 8x. So 12 equal to 2x and x equals 6. Okay, so x equals to 6. Alright, so that's the part 1. Now part 2, notice this time we got some we have some bunch of log equations. So let's go ahead and go with that. So in general, when you're solving a log equation, you only want a single log. Okay. So let's look at what we have. So you have a log of x plus log of x plus 3 equal to 1. So that means in this case, we want a single log. So that means this needs to be combined. And how do we combine? When you add the logs together, you multiply by the inside. Remember this rule? Log A plus log B is the same as log of AB. Okay, so we're going to use this property right here and we're going to combine it. So this is log of x times x plus 3 equal 1. So you get log of x squared plus 3x equal to 1. So step 2, once you have the form a log of x equal to b, we change to exponential. Okay. All right. So in this case, right? Once we Actually, you know what? This a should not be there. Sorry about that. We don't need that a. Alright, so in this case, right, we have log base 10 of x squared plus 3x equal to 1. Let's change it. So this means 10 to the first power equal x squared plus 3x, which means x squared plus 3x minus 10 equals 0. And this one I think is factorable. X plus 5, x minus 2. So that means x either equal to negative 5 or x equal to positive 2. Okay. And make sure we check. Make sure we check this if it works. Remember, log, the domain for log is not all real numbers. So we have to check. Alright, so here we go, let's check. I'm going to check out on top of here. So if x equal to 5, x equal to negative 5, sorry, that means you got a log of negative 5. And right off the step, no good. You can't take a log of a negative number. Now check with x equal to 2. You get a log of 2 plus log of 2 plus 3, which is log of 2 plus log of 5. And remember, when you have log of something plus log of something, you multiply the inside. So this is log of 10. And if you punch in the calculator, right, or you can do this by hand, log base 10 of 10 is 1, the exponent. Okay. So, general rule of thumb when it comes to solving log equations, you need a single log, and you need to make sure it looks like this. And the last step, change to exponential and solve. Okay? Alright, let's move on to the next one. Alright, part B. Part B, you have a log of x plus 2 equal log of 7 plus log of x. Okay? So in this case, we can go ahead and combine, right? So you can have log of x plus 2 equal log of 7x if you want. And check this out, right? Notice, this is very much like the property we had earlier. Remember, the property for exponential looks like this. A to the b equal a to the c. This implies b equal to c, right? So in this case, if you think about log of a equal log of b, that should make sense that a equal to b here, doesn't it? So if that's the case, we can use this rule right here. This is the same as x plus 2 equals 7x. Right? They have the log the same base, so the inside's got to be the same. So from here, solve for x. 2 equal 6x. X is 1/3. Okay. All right. There's definitely some tricks here and there, but the more of these you do, the easier they become. All right, here we go. Natural log of 87 minus natural log of x equal natural log of 29. So in this case, this is natural log of 87 divided by x, and that's equal to natural log of 29. So in this case, again, use the same property as the last one. Natural log of a equal natural log of b. That means a equal to b. So in this case, we have 87 over x equal 29. So 87 over 29 is equal to x. And I'm not quite sure what the answer for that one. So let's see what calculator says. Did they give us anything nicer? 87 divided by 29. You get 3. All right, and once you get 3, we can plug in and double check, and the natural log of 3 is okay. So I think everything should be fine. Okay. So that was solving a bunch of log equations. Now for the next set, you're solving exponential equations. So you got 4 to the 3x minus 1 equal to 10, right? So the suggested rule is this. Isolate b to the x. So in this case, if you want to isolate b to the x, I have 4 to the 3x equals 11. Okay. So once you got the b to the x by itself, next thing we have to do is log both sides to bring the variable in the exponent down. So you look at the example. Once you take a log of both sides, the 3x can be put in the front, like 3 times x times log of 4 equal log of 11. So from here, we're going to solve for x. So that means I have to divide everything by 3 log of 4. So 3's will cancel, log 4 cancel. So x equal log of 11 over 3 log 4. Okay? Alright. Okay, let's go ahead and move on to the next problem. This problem right here, you have 5 to the x plus 1 equal 9 to the x minus 1. And notice, I can't get these into the same base. I can't make the 5 and 9 into the same base. Okay, so this one won't be as easy as the first set of questions. Okay, so what we're gonna do is that, well, we're still going to take a log of both sides. So if I do, if I do log of 5 to the x plus 1, that's gonna be equal to log of 9 to the x minus 1. And remember, the property says when you take a log of something to a power, the exponents can be put in the front. Okay, so this is x plus 1 times log of 5 equal x minus 1 times log of 9. Okay, now from here, all you have to remember is this. Log of 5 and the log of 9 is just a number. Okay, they're just numbers. Okay, so what we can do is we can distribute. So I'm going to distribute them. So I'm going to distribute the log of 5 times x. So it'll be x log of 5 plus log of 5, because log of 5 times 1, which is log of 5, equal. Same thing here. Distribute. X log of 9 minus log of 9. Okay, and from here, this is actually a linear equation, because if you look at the exponents on the x, these are all to the first power. Okay, so I'm just gonna move all the x's to one side, and any numbers that does not have x to the other side. So I'm going to minus x log of 9 on both sides. Then I'm going to minus log of 5 on both sides. So I get x log of 5 minus x log of 9 equal negative log of 9 minus log of 5. Okay? And from here, what I can do is I can actually factor out x. So I get x times log of 5 minus log of 9 equal negative log of 9 minus log of 5. Okay? And then and to figure out what x is by itself, right? I can get x by itself by dividing both sides by log of 5 minus log of 9. And this right here is my answer for x. Okay. Not pretty, but it gets the job done. Okay, it is not pretty, but it does get the job done. Okay. Now, for that problem, there's some alternative ways that people sometimes would like to try, and I'll show you what some people might do. Instead of using regular log, some people use log base 5. Now, if you use log base 5 for this question on both sides, what you ended up with is that, if you remember the property, right, this log base 5 of 5, what you end up getting is just the exponent. Okay? And where log of base 5 to the raised to the x minus 1 power, that becomes x minus 1 times log of 5. Log base 5 of 9. Sorry. So it does make things look a lot easier because you still have to distribute. That needs to be distributed still. X plus 1 equal x log base 5 of 9 minus log base 5 of 9. We still had to get all the x's on one side, so I can minus 1 on both sides and minus x log base 5 of 9 on both sides. So I end up getting x minus x log base 5 of 9 equal negative log base 5 of 9 minus 1. I still had to factor the x out. So you're left with x times the quantity, 1 minus log base 5 of 9. Now, if you're ever not sure, multiply the x back to see if you get the original. Equal negative log base 5 of 9 minus 1. And from here, I divide both sides by the 1 minus log base 5 of 9 on both sides. And this right here is our solution. Okay, it's just you get the same value like you did before, it just looks slightly different. Now some people do it this way. You can do it if you want, or you can just use regular log or natural log. It doesn't matter, you'll get the same answer anyway. So, alright, the last problem in the set 4, you have 250 over 1 plus 4 e to the negative 0.06x equal 200. Okay, so the easiest way on this is I will actually set 200 as 200 over 1, and then I'm going to cross multiply. And if I do that, I get 250 times 1 equal 200 times by 1 plus 4 e to the negative 0.06x. Okay? Now, if you want, feel free to distribute. I think most people would do that. So you get 250 equal 200 plus 800 e to the negative 0.06x. From here, let's just go ahead and isolate. Right? This is an exponential equation. And when we solve exponential equation, we always isolate b to the x, right? If you look at the previous definition. So that means we have to isolate e to the negative 0.06x for this problem. All right, let's go. Minus 200 on both sides. You get 50 equal 800 e to the negative 0.06x. Now divided by 800 on both sides. What is this? I think you get 1 over 16 is e to the negative 0.0006x. Now from here, if this is the base e means you need to use natural log. So I'm going to take natural log of both sides. Okay, so which means we can take the exponent and put it in the front. And from here, if you remember, natural log of e is 1. Right? Because natural log of e is log base e of e. This is 1. This is property number 1 or number 2, I think. I can't remember. Okay? So what we end up having is simply natural log of 1 over 16 equal negative 0.06x. So to figure out what x is, I'm going to divide both sides by negative 0.06. Okay, I am happily to accept this as the answer. Okay, I'm totally happy if you have this as a solution. Totally cool. Okay, so basically this will get you through solving exponential equations and log equations. Hopefully you'll have all the properties memorized by the time the assessments here. Okay, now let's get through applications. All right. So we're gonna revisit the compound interest problem, right? So here we go. Ric Flair is wondering how long it would take to an investment of $12,000 compounded daily at a rate of 3.5% to reach a balance of $18,000. Let's help him out. So before we start, let's go ahead and write down our equation for compound interest. A equal P times 1 plus R over N raised to the NT power. So in the case for Ric Flair, we know he wants to invest $12,000. We know he wants to have an interest of 3.5%, so which means 0.035. Compounded daily, so daily is 365 days. Now so what else we know? We don't know how long it's going to take. So which means we have no idea what t is, but at least we know 365 is the end. So we'll have 365t here. And hopefully by when this is all said and done, we should have $18,000, right? Ric Flair should have $18,000 by the time this is all said and done. Okay. All right. So here we go. Now, so again, this is an exponential function, exponential equation, because the variable is in the exponent. So we need to isolate b to the x. So the base raised to exponent. Alright, so that means in this case, we need to isolate this. This needs to be isolated. Alright, so from here, that means I need to divide both sides by 12,000. So that means if I divide both sides by 12,000, I end up getting 1 plus 0.035 over 365 raised to 365t equal 18,000 divided by 12,000. Which is, cross out the zeros, you get 18 over 12, which is 3 over 2. Okay? Alright, so I'm gonna go to the next page. 1 plus 0.035 over 365 raised to the 365t is equal to 3 over 2. Okay? So now notice, right, there's no coefficient here, which is good. Let's go ahead and take a log of both sides. You can use log or ln, it doesn't matter. Alright, so we take a log of both sides. Now, once you take a log of both sides, again, remember, this is exponent that goes in the front. So you have 365t times natural log of 1 plus 0.035 over 365 equal natural log of 3 halves, which is 1.5. Let's just make it a little easier. Okay? Now, again, remember, we're solving for t. Right? And t is no longer in the exponent. T is now in front of the log. So which means what we have is now a linear equation. So all we have to do on both sides is we're going to divide it by 365 natural log of 1 plus 0.035 over 365. Do that on both sides. Okay, 5 over 365. Okay, so now let's see what happens here. So you got natural log of 1.5 divided by 365 times natural log of 1 plus 0.035 over 365. So let's actually punch in the calculator to see what we have. So natural log of 1.5 divided by 365 and divided by natural log of 1 plus 0.035 divided by 365. So this is going to be 11.59 years. Okay, so in order to reach $18,000, it's going to sit in the bank for 11.59 years, which that's not a short time. Okay, that's not a short time. But yeah, but definitely the compound interest problems where we used to be able to only ask one type of question. Now we can ask to see what the value is in the exponent, and you're going to be able to solve it. Okay? Alright, let's move on to the next problem with mortgage. Alright, so the part B, there is a formula that I will provide on the test if I do give you one. Okay, so here we go. So this is the formula that we use to calculate mortgage. And yes, I actually verified it because when I was buying the house, I did try to use this formula to see if I get the same thing, and I get exactly the same value. So this formula is legit. Okay, so here we go. So P equal A times R over N divided by 1 minus 1 plus R over N raised to the negative NT. Okay, so pretty much the same. R is the interest rate, right? In decimal, please. A is how much money financed. Money financed. So P is the monthly payment. And N is number of time, but usually we just call it 12 because we do monthly payments. And T is number of years. Okay. So here we go. So Governor Snyder, right, former governor by now, is buying another cottage on the shore of Lake Michigan, and he saw one for sale for $1 million. What would his monthly payment be if he took out a 30-year mortgage for the entire amount at a 3.75% interest? So if this was a scenario, so this is what the formula is going to look like. We're trying to figure out a monthly payment, but I know the amount financed is $1 million. You can say it in Dr. Evil's voice. I will not judge you. Times 0.035 for 375 for 3.75% divided by 12 all over 1 minus 1 plus 0.0375 divided by 12 and raised to negative 12 times 30. Now, I suggest you calculate this in groups. So let's go ahead and use our calculator to figure out what the numerator is first. Okay, so you got 1 million times 0.0375 and divided by 12. You get 3125 all over. Now, with the graphing calculator, you have the fraction button. So I'm going to see if I can make this into a fraction using a calculator. I'm not quite sure if that's going to happen or not, but we'll see. Okay, so I'm going to test it out right here. 1 plus 0.0375 divided by 12. Math, fraction. This is actually 321 over 320 raised to the negative 360. Okay, so that's not bad. I like fractions. Fractions is easy to work with. So then what I'm going to do is I am just going to keep the top, and I'm going to use the calculator to figure out the denominator. So 1 minus parentheses 321 divided by 360, close parentheses, 320, not 360, 320, close parentheses, raised to negative 360. Okay, let me just double check my math again. Something doesn't look right. I see a problem now. There we go. You end up getting 0.674777540 and so on. All I'm going to do is I'm just going to keep that decimal in the calculator and just divide it straight out on the calculator. So this is 3125 divided by the crazy looking decimal, and you get 4631.16. So his monthly mortgage payment on this cottage would be $4,631.16 per month for next 30 years. Okay, so 46, 31, 16. Yeah, so you can definitely figure out how much your mortgage payment is. If you are thinking about buying a house, this definitely works. Okay, part B, or the second Part 2. Previous question. If Governor Snyder decided to increase the monthly payment by $500 in order to pay it off faster, how long would it take to pay off the mortgage? Okay, so let's figure this out right here. So what he's doing is that this time we're still using the same formula. But this time we're trying to figure out what happens if payment goes up and what happens with time. So we're trying to figure out what the time would be. Okay, so let's go ahead and plug everything in. Now we know the payment is $500 more, so that means instead of 4631.16, we're going to add 500 to that. So that's going to be 5131.16. Okay, so our monthly payment now is 5131.16 equal 1,000,000 up here times 0.0375 divided by 12 over 1 minus 1 plus 0.0375 over 12 raised to the negative 12t. Okay, so we just plan on plugging all the numbers in. And from here, we can actually borrow a lot of the result from the previous question. Notice the previous question, what we had was what? It was 3125 on top. Right, so this is 5131.16 equal 3125 on the top. On the bottom, we have 1 minus, now this doesn't change, that's 321 over 320 raised to the negative 12t. Okay, so from here we need to solve for t. Now, we did a problem like this earlier. This is like the problem on number 4, right? Parts in the parts. The problem set part 3, number part C, the fraction equal 200. That's exactly what we're going to try here. Okay, so in this case, what we're going to do is we're going to set this as over 1, and we're going to cross multiply. So you get 3125 equal 5131.16 times by 1 minus 321 over 320 raised to negative 12t. Okay. Right. So if you want, you can distribute. So you get 3125 equal 5131.16 minus 5131.16 times parentheses 321 over 320 to negative 12t. Calculator. So we minus 5131.16 on both sides. So 3125 minus 5131.16. I get.
Are you gonna try it again now?
Let me see. Oh, wait a minute. I made a mistake on my calculation. 3125 minus 5131.16 is negative 2006.16 equal negative 5131.16 multiplied by the 321 over 320 raised to the negative 12t. sorry, I ran out of space. Okay, so up here, I am going to erase this part, so we have some space. So I get, let me just recopy that over, negative 2006.16 equal negative 5131.16 times by 321 over 320 raised to the negative 12t. So from here, I am going to divide both sides by negative 5131.16 so divided by negative 5131.16. So this is going to be 0.3909759 ... equal 321 over 320 raised to the negative 12t. Okay. Now again, this is a exponential equation, so we need a log of both sides. So I'm going to take a log of both sides right here. Natural log of 0.3909759 equal negative 12t natural log of 321 over 320. Okay, I took the liberty to just bring the exponent out, put it in front of the log. Alright, we're almost done. Now we need to get t by itself. So which means we divide by everything else. So divide both sides by negative 12 natural log of 321 over 320. So that's going to be so again, divide both sides by negative 12 natural log of 321 over 320. Let's see what we have. Okay, natural log of that divided by negative 12 divided by natural log of 321 divided by 320. I get t equal 25.08 years. Okay, so if he increase the payment by $500 a month, he will cut down the time by almost 5 years. Okay, so this is the reason why for credit card, for mortgage payments, we want to make sure you pay extra, not just minimum payments, because otherwise you'll never pay it off. Okay. All right, the last question. Jill graduated from Michigan State University with $40,000 in student loans. How much is her monthly payment if she plans to repay the loan in 20 years at 3.5% interest rate? So we know the amount borrowed is $40,000. Whoops. Interest rate is 3.5%, which is 0.035. We're doing the monthly payment, so N is 12. And she's very ambitious. Her T is 20 years. Okay, so let's go ahead and plug this in. So I got 40,000. So P equal 40,000 times 0.035 divided by 12 over 1 minus 1 plus, let's see, 0.035 divided by 12 raised to negative 12 times 20. Alright, so again, calculator, let's see what we have. 40,000 on the top, 40,000 times 0.035 and divided by 12. So you get something that's not as nice. So I'm just gonna keep it as 350 over 3. Okay, if you got a graphing calculator, they have a fraction function. So this is again 1 minus 1 plus let's see what 1 plus, so let's figure out what that is. So 1 plus 0.35 over 12 to a negative 240. Calculator says 1 plus 0.035 divided by 12 plus 0.035 divided by 12 is 2407 divided by 2400 raised to negative 240. Alright, I'm going to punch all that in the calculator. 350 divided by 3 divided by parentheses 1 minus parentheses 2407 divided by 2400 close parentheses and raise it to negative 240. Okay. Alright, so here we go. So it looks like what we end up having here is a monthly payment of $231.98. Okay. Alright, so that's the monthly payment, which is still a lot, but I guess we're just gonna have to do the best. She'll do the best she can, and to pay this down. Okay, so here you go. Definitely, there's a lot of stuff happening in chapter 5. So make sure you know what's going on, and if you don't know, that's okay. Hit us up. You can hit me at my email whsieh@grcc.edu. Office hours from 6 p.m. to 8 p.m. Or you can post stuff on Blackboard, on the forum, or you can check out the Math Lab. Alright, good luck, and let me know what's going on. I'll talk to you soon. Okay, bye.